All right, so here's the unnecessarily long example problem, right? So a 13.5 ohm resistor has a peak voltage of 207 volts across it, right? And of course, the first thing you want to do is don't use peak voltage, right? What is the RMS voltage across it? So I'm going to use the RMS is equal to V peak over the square root of 2, right? So that's going to be 207 divided by the square root of 2, which is approximately, let's see, square root of 2. That is 146.37. Right, and this is the voltage that I would use to calculate the power, by the way, right? What is the peak and RMS current through it? Okay, I can do this. The peak current is going to be, I'm going to use I naught is equal to V naught divided by R, right? I know they don't write it that way, but there it is, right? Okay, so that's going to be 207 over 13.5. Right. By the way, there's no such thing as a peak and RMS resistance. Okay, it's just resistance. So 207 divided by 13.5 is 15.3, a lot of threes. That's the peak current, right? That only exists for just that instant when you're at the top of the peak or the bottom, right? Just here and just there, just an instant in time. It's almost never that. Which is why you'd want to use the RMS current. So let's see. What is the RMS current? Okay, so the IRMS is going to be I peak divided by the square root of 2. So that's 15 point a lot of threes amps divided by the square root of 2. So I'm going to divide by the square root of 2. And I get 10.842. So this is my RMS, sort of my average current, right? On the average, kind of, it's that, right? Okay, it gets a lot higher when it gets to 0, but on the average, in terms of power, that's what it is, right? It's not a time average, but it's like a power thing. Okay. What is the average power and the peak power? Oh, okay. Okay, so average power, we've got these two things, right? Let's find the average power a number of ways, shall we? The first way I'm going to find is just go IV, power is IV. You only have to find it one way, right? Okay, but when you do power, you've got to use the RMS, right? So I'm going to use RMS. I'm going to go 146.37 times 10.842, right? By the way, I just did V times I. I'm sorry about that. Okay, so I'm going to go that guy. I'm going up arrow with my calculator times this guy. And when I do that, I get this number that comes out absolutely even, 1587. And of course, that's not a great mystery because there's a square root of 2 in the bottoms of this, right? And so basically, I'm taking some number and dividing by 2, right? I'm still finding the average power, right? The other way I could have done this is I could have said power is I squared R, right? And I would use the average RMS, right? So I go 10.842 squared times 13.5. All right, so let's find that. There it is. Boom. Squared times 13.5. I get exactly the same thing, 1587. I could also find it. Power is V squared over R, but I know you've got other things to do, so try that. Okay. Now we want to know the peak power. Well, the average power is 1/2 the peak power, right? Okay. So I could just multiply this by 2, but let's have fun. Let's figure it out using the how can we do? Oh, 2. Let's do this. The peak power will just be peak voltage squared divided by R, right? Let's do that. That's the easiest way. So 207 squared divided by 13.5. 207 squared divided by 13.5. That's 3174. Which is exactly twice this, right? Because of that, right? Another way I could find it, I could do I squared R, right? Power is I squared R, right? So peak power would be peak current, so I'll use this guy, right? So the peak power is 15.33333 squared times 13.5. Now, did I show you guys how to type in repeating decimals? I'll show it to you sometime. If you ask me, I'll show you. Then don't forget to square it times 13.5. Are you laughing? I don't even know. I can't even tell. 3174. I get the same thing, right? All right. Do all these annoying whiteboard problems because this is tricky stuff, okay?